So far we've learned how to differentiate sums, differences and products. The product rule was the last more complicated rule that we've learned. So let's tackle the last elementary operation. How do you take the derivative of a fraction? So h of x is the quotient of the fraction of f over g, and there's a rule just for that called the quotient rule. Later on we will see that the quotient rule really is the product rule in disguise, due to the fact that every quotient, every fraction, can be written as a product. So how do we see that? This is simply f of x times g raised to the power of minus 1 of x. So there's a product, so we could apply the product rule. However, we haven't learned the chain rule yet, and for any functions g that are not simple, such as x squared, the ddx g to the minus 1 of x will be difficult to compute unless you know the chain rule. Of course, for x squared, this would be x to the minus 2, and we already know how to form ddx of that. So let's see what could h prime of x be. It looks a bit like the product rule, but fraction in, fraction out. So this is a fraction. The numerator is simply f prime times g, but now there's a minus f times g prime, and the denominator is simply g squared. And of course I should put a parenthesis x parenthesis everywhere, but let's save that work. So this is it. It looks similar to the product rule, as I said, but it's a bigger expression, and you will see that quotient rules often lead to rather lengthy expressions, not quite as short as the product rule. Let's try it out. So what if I gave you this function h of x equal to x squared minus 1 over x plus 1. So then we see, let me write h prime different fashion as ddx of h. I can put h up here in front, it's up to me, h dx equal to h prime. So quotient rule, f prime is ddx of this term, that's just a 2x. Now don't forget your parenthesis times g, and that is x plus minus f. Again, don't forget the parenthesis, that's the original term x squared minus 1 times g prime. Now what is g prime? It's ddx of that term. The plus 1 falls away, it's a constant, and the slope here is just a 1, so this is a 1. This whole fraction is divided by g squared, which is just x plus 1 squared. Now the numerator will be 2x squared plus 2x minus x squared minus minus 1 divided by, x plus 1 squared. And now we see that the numerator now becomes a simpler expression, namely x squared plus 2x plus 1 divided by the same thing, and we see that the above, that the numerator is simply the binomial formula, x squared plus 2bx plus b squared. So we can rewrite the numerator as x plus 1 squared divided by x plus 1 squared. This lengthy expression collapses to b. So that means the slope is equal to 1 everywhere, independent of x, which would suggest that the original function h of x really was linear and not quadratic, as it suggests here. How do we see this? By noticing that the numerator here is the third binomial formula. So I can rewrite this as x plus 1 times x minus divided by x plus 1. And these two cancel, left with x minus 1. And yes, if I now take ddx of this new h, I'm left with a slope of 1.